Alright, back at it again now in 6-4. We're looking at compound events. This is simply when you have two things happening that we're interested in. Actually, I should say two or more things. And they can happen at the same time, but you can also separate them, one first and then the next, and that's a common mistake. If you're rolling two dice, it really doesn't matter if you roll them both or roll one and then the other. If you're choosing two socks from your drawer, it doesn't matter if you choose both and then look at them or choose one and then the other. Okay? So here's an example. Just suppose you're choosing two pens from your book bag. Okay? You could choose two at once or one after the other. Alright? If we have independent events, the fact that I've chosen one has no bearing on whether or not I'm going to choose the other one. In this case, if you're choosing pens from your book bag, it usually would mean you're putting them back in and then you're drawing another pen back out. Okay? And the situation is the same in each case. Those would be independent events. If you're rolling two dice, those are not going to affect each other, and those would be independent events. Dependent events, however, the first thing that happens does affect the next event. So if you've chosen one type of pen and then you go to choose another one and you've still got the first in your hand, it does affect how you might choose the second pen. Okay? Then if we've got independent events, if these are things that have no influence one over the other, then we say the probability of A and B happening is simply the probability of A times the probability of B. Alright, we simply multiply them. Alright, so you're playing Monopoly or some board game where you've got two dice and you're wondering what is the probability of rolling double sixes. Well, the probability of rolling one is just 1/6, and the probability of rolling another 6 is 1/6, and you would multiply them and you'd write that as 1/36. Okay, so don't express that as a percentage. That's the easiest way to write that. So part of the hard thing is just determining which things are independent and which things aren't. But ask yourself, do they influence each other? Right? Choosing a card and tossing a coin will not influence each other. However, there are things that are dependent, and when we're asked to find the probability of dependent events, one and A and B happening, we'd say it's the probability of A times the probability of B after A, okay, has been chosen, alright, or has happened. So in this case, in our example, we have a bag of marbles. It has 10 red marbles and 8 white marbles. So what's the probability that we reach into that bag and choose 2 white marbles? We look down and there are 2 white marbles. Well, how we choose them, we could choose 2 at the same time, but it's really important to understand that it really wouldn't make any difference if we chose one, then the other, and then looked at them. So we're going to break it down into those 2 probabilities. Choosing the first marble and it being white would be 8 out of a total of 18, okay? Because that's our probability. The things we're interested in, white marbles over our total. So add those up carefully. And then when we go to multiply, now I've got 1 marble. What's the probability that the next one is also white? There are now only 7 because I've chosen one, and the total number of marbles has gone down by 1 as well. So then I would simply multiply those 2. Okay? Sometimes it's possible to cancel things diagonally and simplify it. Obviously the 8 and the 18 could cancel, and I could have 4 and 9. I still might want to use my calculator, but that's the probability. Alright? What's the probability of 3 red? Why don't you pause the camera, figure it out, come back and check. Alright? So you're back, and red marbles, there are 10 of them out of a total of 18, and then there'll be 9 out of a total of 17, and then there'll be 8 out of a total of 16. Okay, and again, you can do a lot of this in your head where you cancel the 9 and the 18 and write a 2. You cancel the 8 and the 16 and write a 2. Can't cancel the 10, but you've got now a total of 10 over 4 times 17. So would that be 3468? Okay, so that would be the simplest fraction. Well, not quite the simplest. It would be 5 over 33 would be simpler. Alright, our final one, what is the probability of 10 white? Well, if you look at that, you'd go 8, 7, 6, 5, 4, 3, 2, 1, and then you'd be choosing 0 out of something, and when that multiplied, it would give you 0. So don't fall for any tricks like that, okay? Finally, I have one other question. We're going to do problem number 20 on page 326. And it says, based on Massachusetts, and you can ask your parents about this, it's pretty true, you get called for jury duty an awful lot in this state. And apparently statistics show that 1 in 3 people in Massachusetts, when they're called up for jury duty, they actually show up at the courthouse. Okay? And when they show up, they could be put into one of 10 possible panels. Alright, so what's the probability that somebody appears? Well, that's pretty straightforward. That's just 1 in 3. Alright? But what's the probability that they wind up on panel number 2? That would be then 1 out of 3 times 1 out of 10. Okay? 1 out of 30 would be your total probability that any one person chosen for jury duty might wind up on panel 2. Alright? Good luck.